This document tells quite a story when filled out. This tune-up took about 2 hours. It helps to keep variables affecting combustion consistent so as to determine if the adjustments made were correct or incorrect. Therefore, the automatic burner control and damper control were placed in manual. The feed rate was set at 250 tons per hour, and the loader operator was instructed to keep the moisture content uniform. The targets, oil viscosity and draft, were unknown at the beginning of this burner tune-up. The process of completing the tune-up allowed us to know where to target these settings during production. The oil temperature should be adjusted during the tune-up. The oil should be measured for viscosity immediately after the burner is tuned. Document this viscosity measurement and continue to check viscosity from load to load. If the fuel is consistent, the temperature won't need to be changed from load to load, and measuring each load will become less necessary. At the beginning of this, the CO carbon monoxide was so high that incomplete combustion of fuel oil was collecting on the bags. If this were LP or gas, the problems are the same, except the bags do not get oily and plugged. The O2 oxygen was high as well. We had a choice to adjust the fuel or air or other variables that affect combustion. We chose adjusting the fuel pressure first. Some adjustments are hard to make, so we normally save them till last if they in fact need adjusting. It is easier to adjust fuel pressure, exhaust damper, compressed air pressure, fuel temperature, spin vane settings than adjusting combustion flights, air-fuel valve linkage, flame holders, etc. Take some time to understand why the corrective, sometimes incorrective, adjustment at the end of one row affected the resulting changes in the following row. Notice that the fuel pressure was initially decreased twice and then increased once. We need to overshoot to determine where the best setting is. The final stage of adjustments should leave the combustion lean. This helps keep bags from being oily and exhaust gases from being explosive. Notice how the dryer exit temperature had changed from 225 degrees to 255 degrees and the burner position had remained the same. True story. Natural gas. Burner control and damper control was placed in manual. Exhaust fan damper was adjusted for more air and the mix temperature went up to 20 degrees. The air-to-fuel ratio was excessively too rich. Adjust to your controls and pay attention to your instrumentation.
What is the easiest method available to confirm that the damper mechanism inside the burner actually changes the flow of air to the center of the flame? The correct answer is C. Place a clamp-on ammeter on one of the burner blower motor leads and watch the amperage significantly change from near no-load amperage to full-load amperage.
Fuel and blower damper adjustment. The burner position motor 1 is linked to air damper 2. The air damper is linked via arm 3 to fuel valve 4. Knob 5 is used to adjust the burner for idling in the low fire position. The low fire position switch is located in the burner position